We're given a polynomial with a couple of possible binomial factors. We want to see if these are factors or not. The factor theorem says if you get a remainder of 0, when you divide, then something is a factor. So for this problem, I'm going to take a look at our original polynomial here, 2x to the 4th minus 5x cubed minus 23x squared plus 38x plus 24. I want to see if that is evenly divisible by this first possible factor, an x minus 4. So what I'm going to do is I'm going to do an x minus 4 equals 0 and then solve that by adding 4 on both sides. That would give me x is equal to 4. So when I set up synthetic division and check this x minus 4 out, the number I'm putting out in front is a positive 4 because of that x minus 4. For our original, we do have all of our powers of x, so I don't need any zeros there. Simply a 2, negative 5, negative 23, 38, and 24 is all we need. We don't need any zeros holding one of those columns because we have all of those powers of x. All right, so let's do the synthetic division. If we get a remainder of 0, then x minus 4 is a factor. If we get any other number, then it's not. We bring the 2 down. 2 plus nothing is 2. And then from there, multiply by the number in front. 2 times 4 is 8. I put that in the next column, and since that's a positive, I'm going to handle this like a negative 5 plus 8. And negative 5 plus 8 is 3. 3 times 4 is positive 12, so I want to do a negative 23 plus 12, which would give us a negative 11. 4 times negative 11 is negative 44. 38 minus 44, that is a negative 6. Our negative 6 times 4 does give us negative 24. And then in that last column, 24 minus 24 is 0. That last number is our remainder, so we did end up with a remainder of 0. So x minus 4 is definitely a factor, and we can take the original and do a little factoring. What we just said is x minus 4 is a factor, because when we did synthetic division by 4, we got a remainder of 0. So this original, we can rewrite it with some factoring using an x minus 4, and then the other factor ends up being our quotient down here on the bottom, our depressed polynomial. This is a constant term. The first number over to the left of that vertical line is constant, then x squared, x cubed. So we have a 2x cubed plus 3x squared minus 11x minus 6. From there, we want to go through and determine if a 2x plus 1 is a factor or not. So we're going to handle this the same way. There's 2 ways of doing this part. For these problems, this is the easiest. Do the same thing we did here. Set this equal to 0. So if I did 2x plus 1 equals 0, and I started solving, moving that over to the other side, if I subtracted 1, I would have 2x is equal to a negative 1. And then if we divide by 2, we would end up with x is equal to a negative 1/2. So I'm going to do synthetic division again to see if this 4-term polynomial factors. When I do that synthetic division, I'm going to check and see if a 2x plus 1 is a factor or not. So I need the negative 1/2 out in front. And then our numbers across here, those are going to be from this polynomial, which do happen to be the same numbers as our depressed polynomial. So we can use that depressed polynomial to get this next part set up. From there, 2 plus nothing is 2. 2 times that negative 1/2 in front is a negative 1. 3 minus 1 is 2. 2 times negative 1/2 is a negative 1. Negative 11 minus 1 is negative 12. Negative 12 times negative 1/2, we have a negative times a negative, that's a positive, and 12 times a half is 6. And negative 6 plus 6 is 0. So we did get a remainder of 0 again, which means x minus a half, or 2x plus 1 would be a factor. When you do it this way, and you go through and set this equal to 0 and solve, we're going to use, I said x minus, I should have said x plus. We're going to use x plus 1/2. This came from a factor of x minus 4. This would be a factor of x plus 1/2. So we still have the x minus 4 out in front. Now I'm taking this four-term polynomial, and I'm going to break it up using an x plus 1/2, and then these values. Constant, x squared. So 2x squared plus 2x minus 12. In the original problem, they wanted us to determine if x minus 4 was a factor. By plugging in 4 and doing synthetic division and getting a remainder of 0, we were able to break that up into two parts, one of those being the x minus 4. To see if 2x plus 1 is a factor, one of the methods you can use to do this is to set that equal to 0 and solve, which gave us a negative 1/2. So I did synthetic division of the depressed polynomial from the previous step with a negative 1/2, got a remainder of 0 again, which means that this four-term polynomial can be written in two factors. One of them is an x plus 1/2, and then the other is from the depressed polynomial, which was a 2 and a 2 and a negative 12, which gave us 2x squared plus 2x minus 12. We are supposed to start with, in the directions, determine if those are factors or not, and they both are. And then we're supposed to go through and factor everything as much as it can get factored. So x minus 4, that's factored and that's done. X plus 1/2, that's factored and that's done. I want to see if this factors some more. First step in factoring is to factor whatever's in common, and there is something in common with all of those terms. It is the number 2. If I factor a 2 out in front, I would end up with an x squared plus x minus 6. We still would have an x minus 4 and an x plus 1/2 out in front. And then to finish the factoring, we want to see if this trinomial now factors, and that would be the add multiply method. We have three terms there, looking for two numbers that add to be a 1 and multiply to be negative 6 times 1, which is a negative 6. There are two numbers that fit that pattern. They are 3 and negative 2. And because we have a 1x squared, we can use the shortcut. So we have a factor of x minus 4. We have a factor of x plus 1/2. We have a factor of 2. And now we can take this trinomial and, using the shortcut, come up with factors of x plus 3 and x minus 2. Usually, when you write down all of the factors, if there's a constant term, we do bring that out in front. But there is a better option on this one. It wouldn't be wrong for us to put that in front. We definitely could put the 2 in front and then have these 4 parentheses afterwards. That would be fine. But if you take a quick look, we do have this x plus 1/2, and we have times 2 here. So we could multiply those together. And if you do that, you won't end up with any fractions in your final answer. So instead of bringing the 2 all the way out in front, I'm going to use the distributive property and multiply by those other 2 values in this set of parentheses. And again, the reason that that's advantageous, if you do 2 times x, you get 2x, and if you do 2 times 1/2, you get 1. So then we don't have any fractions in our final answer. So copying down the x minus 4, 2 times x is 2x. 2 times 1/2 is a positive 1. And then we have our x plus 3, and then our x minus 2. The 2x plus 1 is definitely a factor. If you remember all the way back up here, the 2x plus 1, when we plugged in a negative 1/2, we did get a remainder of 0. So it does make sense at the end that we would have a factor of 2x plus 1 down there. So one possible answer would be for you to take the 2 and distribute it into those two terms so you don't have any fractions. Final answer. Let me erase this little bit of work here so I have a little more room. we went through and we plugged in an x minus 4, got a remainder of 0. So yes, x minus 4 is a factor. Then we took 2x plus 1, and we did synthetic division using that negative 1/2 and also got a remainder of 0. So yes, the second possible factor there was actually a factor. We got a remainder of 0 twice, so it's yes and yes. And then for our final answer, we do want to put down here what our final factored form is. So f of x equals an x minus 4, a 2x plus 1, an x plus 3, and an x minus 2. So when you check your work on a problem like that, we have yes and yes because the two factors they listed did work, and then our final factored form.